Hello, welcome back for lesson 2.4. We're going to be adding on to our knowledge of matrices. In lesson 2.3, we learned about a matrix and how to add and subtract them. And now we're going to learn how to multiply them. So you can multiply a matrix by a single scalar, so a single value, by distributing that value to every element in the matrix. We can also multiply two matrices together. So if we do that, if we have a matrix M times N right here, and matrix V, which is N times K, to find the element in the ith row and jth column of the product AB, multiply each element in the ith row of A by the corresponding element in the jth column, and then add these products together. So we have to make sure that the rows of A are the same as the columns of A are the same as the rows of B. Also, I want to note that A times B is not the same as B times A in matrix multiplication. So I'm going to give you a little example with some letters. So if I had this matrix here of F, G, H, and I times this matrix of J, K, L, and M, this first element here in the new matrix would be F times J plus G times L. And then we would have F times K. So I'm going to do that one in another color, in blue. So this is going to be, whoops. Whoops, that one's two whoopsies. It's going to be F times K plus G times M right here. And then we're going to H times J plus I times L. And then we're going to have H times K plus I times M. So we're going to do one with numbers here in just a minute. Go ahead and flip the page. So this says, determine if the following statements are true or false and explain why. So it says, any matrix can be multiplied by a scalar. Is that true or false? That is true. Any matrix can be multiplied by a scalar. A matrix can always be multiplied by itself. That is not true because, for instance, if you had a 3 times 2 matrix and you tried to multiply a 3 times 2 times a 3 times 2, these are not the same, so that won't work. It says two matrices can be multiplied only if they have the same number of rows and columns. That's also false. They have to have the columns from the first one has to be the same as the rows from the second. That's what has to be true. So that's false. D says if the product of A, B of the matrices A and B does not exist, then the product of BA does also not exist. And that is false because I said BA does not always equal AB. So this one might not exist, but this one might exist. Okay. So let's look at examples. This gives us a numerical one to look at. So we're going to multiply A times B. So, and A is a 2 by 2, and B is a 2 rows by 1 column. So that is going to give us 2 rows by 1 column. So we're going to have 2 times 3 plus a -1 times a -2. And that is 6 plus 2 is 8. And then we're going to have 5 times 3 plus 8 times a -2. And that'll be 15 plus a -16 is a -1. Now I want to show you how this is also done on your TI-84. So you can see here, if you go to second and x to the -1 and put in the matrix, you will enter the matrix here in A, and then I enter the second matrix in B, and then you'll do A times B to get that. The next one I'm going to show you using the TI calculator to where you can actually see me typing them in. So I'll point out how to do that. So let's look at everything together. So we're going to hit our, so example 3, I'm going to show you how to do it using your calculator so that you understand, because that's the most efficient way. I'm not expecting you to do them by hand. So we're going to go to second and matrix, and then we're going to arrow over to edit, and we're going to edit A, and A is a 2 by 3 matrix. So we have 5, 2, 7, 6, 1. Oh, I forget it likes it. Enter 5, enter 2, enter 7, 6, 1, 0. And actually, this is not correct. It's really a 3 by 2. And there we go. So let's see if it corrected it. 5, 2, 7. Nope. 5, 2, 7, 6, 1, 0. Okay. We have that one in. Then quit out of there. And then we're going to go back in second and matrix, and we're going to arrow over, and I'm going to edit second one. And this is a 2 by 3. This one is the 2 by 3 that I looked at. And so we have 1, 4, 0, 2. Go down here. 1, and 2, and go up and see what it looks like. So 1, 4, 0, 2, -1, 2. Okay. So now to do A times B, we're going to quit out of here. And then you're going to say second and matrix. And in the very first menu column, you're just going to hit enter because we want to multiply A. And then you can go back and hit second and matrix. And we're going to go down and choose B. And we're going to multiply them. And it gives us the multiplication. And that should be a 3 by 3 because this was a 3 by 2 and a 2 by 3. So let's leave that up there. I'm going to go back and share my paper screen because I want us to validate by hand just one of the elements here. Okay. Let's just validate the very first one. Should be 5 times 1 plus 2 times 2. So that should be 5 plus 4 should be 9. Okay. Let's just go back and share my screen again. There it is, 9. So we have 9, 18, and 4. 19, 22, 12, 1, 4, and 0. Excellent. Okay. So let's go ahead and flip the page. And now, again. So it says cost analysis. Cost analysis. The 4 departments of Spangler and need to code the following amounts of the same products. They have the 4 departments here, and they've got paper, tape, binders, memo pads, and pens. And these are the amounts that they need. The unit price in dollars for each project is given below. So they've got paper, tape, binders, memo pads, pens, and for supplier A and B. It says use matrix multiplication to get a matrix showing the comparative cost for each department for the products from the 2 suppliers. So we have up here, if you think of this as a matrix, we currently have a 4 by 5 matrix, and we'll call this one A. And then down here, we have B. This is a 5 rows times 2 columns. So if we do A times B, we are going to end up with a 4 by 2 matrix. Okay. And it will show the cost for each department for the products from the 2 suppliers. Okay. So let's go back to our tracking calculator. And we are going to go back to our matrix. And I'm going to put one in C here. And so this is going to be my 4 by 5. So let's go ahead and enter that. And go ahead, you should be practicing this right along with me or pausing. Oopsie. 7, 2, 3, no, there should be 2, 8, 7, 5. My fingers were going too fast for the computer. To quit out there and go back, and I'm going to enter the next one in D. Actually, you want to be an edit in D, and this one is a 5 by 2. matrix. And then we're going to multiply A times B. Oh, actually, I'm calling them C and D. I'm going to correct that. C and D. I'll correct my paper here. So we're doing second in matrix, and I'm choosing B. And then second in matrix, and I'm choosing D. And that is what we get. Okay, I re-looked at that, and that did not look right. So I noticed that in my first, for paper in department 1, I had a 1 instead of 10. So when I redid it, this is the matrix that we get. 57, 41, 27, 39, 70, 54, 40, and 40 is the total cost. Okay, so I'm going to go back to my paper for just a moment here. So this is where I had a 1 instead of a 10. So that was my mistake. So here is the cost for paper, tape, binders. I'm sorry, for the 4 departments. So department for supplier A is 57, department 2 is 41, 27, 39. That's what it's. These are all departments. And this is supplier A and B. And then question B says, find the total cost over all departments to buy products from each supplier. So that would be adding up supplier A if I add this column here, we get 164. And then supplier B, total cost is 204. So it looks like we should be buying from supplier A. They're a better deal. Stop, pause, rewind if you need to. The example 5 is about shoe sales. Sal's Shoes and Fred's Footwear both have outlets in California and Arizona. Sal's sells shoes for $80, sandals for $40, and boots for $120. Fred's prices are $60, $30, and $150 for the same shoes, sandals, and boots, respectively. Half of all sales in California stores are shoes, a quarter are sandals, and a quarter are boots. In Arizona, the fractions are 1/5, 1/5, and 3/5. Write a 2x3 matrix called P, representing prices for the 2 stores and 3 types of behavior. So P is going to be a 2x3. So it's going to be California and Arizona. So it's going to be Sal's and Fred's. So Sal, just so we can see it. And it's going to be shoes, sandals, and boots. It's good to write out in words what they mean because we're new at this whole thing. So $80, 40, and 120. And then 60, 30, and 150. Now B says, write a 3x2 matrix called F, representing the fraction of each type of footwear sold in each state. So we are going to have shoes, sandals, and boots. And we're going to have California and Arizona. So this will be California, and this will be Arizona. So this was half, 1/4, 1/4. And they have to add to 1, and they do. And this was 1/5, 1/5, and 3/5. And this row, this column adds to 1 as well. Okay. Now, it says only one of the two products, PF and FP, is meaningful. Determine which one it is, calculate the product, and describe what the entries represent. So P is a 2x3, and let's write it here, 2x3. And F is a 3x2. So we can do PF. That would be a 2x2, right? So that would be Sal's shoes multiplied by, it would be Sal, all of the prices for Sal's shoes in California. And then all of Fred's shoes in California. So PF would be Sal's total price. Let's see, total sales for California. And then it would be Fred's total sales for, because it would be a 2x2. So it would be Sal's, it would be each of their total sales in each state. Okay. That would be, and then FP. So if we did F and P, F is 3x2 and P is 2x3. So it would be multiplying this one first and then this one. So it would be shoe price of Sal and Fred's price of Sal. Wait, it would be, sorry, shoes in California at Sal's. It would be this way, sorry. It would be the shoes that each of them are going to sell, the total in the shoes for Calif. So it would be Sal's California sales and Fred's California sales. because it would be 1/2 times 80, and then 1/5 times 60. So it would be, because this would end up being a 3x3. So it would be the total that they would both sell for shoes, sandals, and boots in California, and that the total that they would sell for shoes, sandals, and boots in Arizona. So I don't think we care about what they're selling total in each state by type. I think we want PF, which is going to be each of their sales in California and Arizona. So sales, total sales in California. And then sales, total sales in Arizona, then Fred's total sales in California and Fred's total sales in Arizona. So let's go to the calculator. Let's go ahead and I'm gonna let you take a minute, put your data in. And I will do the same. We've got a 3x2. So it looks like that's what we have already for A. Actually, I'm going to do that as I'm going to put these in. This is a 2x3. So the 80, 40, 120, and 60, 30, 150. Okay. And B, we're going to put it's a 3x2. And and 3. So we said P times F, which would actually be A times B. Oh, let's see, quit. So here, times B. Let's see what we come up with. So let's write down this matrix: 80, 96, 75, 108. And I'm going to describe what they mean. So this is Sal in California, total sales. Sal in Arizona, total sales. Fred in California, total sales. And Fred in Arizona, total sales. Makes more sense. Then D says, from your answer to part C, what is the average price for a pair of footwear at an outlet in Fred's in Arizona? So Fred in Arizona is $108 on average. When we take the proportions that we had here. So that concludes lesson 2.4. Catch me back for the next lesson.